Okay, so in this question, we're told that during the winter months in a certain village in Scotland, the probability of a day having severe fog is 0.06. We're then asked to find the probability that in a given week, there will be either no days with severe fog or 3 or more days with severe fog. So this is going to be a binomial distribution. We've been given some context, but we can interpret that to be a binomial distribution. We've been given the value of p explicitly. Have we been given the value for n? We were told that in a given week. So our n value is going to be 7 days of the week. X follows a binomial distribution, n equals 7, p equals 0.06. Okay, from there we're asked to find the probability there are no days with severe fog. So that translates to a probability statement, probability x equals 0. Typing this into our calculators, we can get an answer quite quickly. So we're going to use the BCD function. 0 is the only value we're interested in, so the minimum and maximum are both going to be 0. Our n value of 7, p is 0.06, hit the enter button, and we get an answer of 0.6485. Probability that there are 3 or more days with severe fog. So that's probability that x is greater than or equal to 3. BCD, minimum we're interested in is the 3. We're going all the way up to the maximum number of days, which is 7, and then our n and p. Here we get an answer of 0.0063. Next, we're told it is known that on a given week there were 3 or more days with severe fog. Okay, this looks like a conditional probability question already. Determine the probability that there are exactly 3 days with severe fog in that week. Okay, so we already know there was 3 or more, and we're looking for the probability that there was exactly 3. We're going to write this out as a given probability, just as we usually would. So what we're specifically looking for is that there's exactly 3 days, and more generally, we knew that there were more than or equal to 3 days. We're looking for the intersection of these two. So this is coming from the formula. The probability of A given B equals the probability of A intersection B over the probability of B. So I hope you can see that playing through here. Let's have a think about the intersection of equaling 3 and being greater than or equal to 3. This is just the probability that x equals 3. If I listed out all the numbers that were 3 or greater, that would be 3, 4, 5, 6, and 7. Which of those numbers are also exactly 3? It's only 3. It sounds like a complicated way to word such a simple concept. Okay, so just make sure you can think your way through that, and hopefully intuitively you can just pull out that that's the only outcome we're interested in. Okay, so I'll actually just rewrite this in a simpler form. It's the probability that x equals 3 over the probability that x is greater than or equal to 3. I've already found the answer for the denominator here. So on the calculator, I'm just going to quickly find the probability that x equals 3. And we get 0.0059. Okay, so I've got 0.0063 as my denominator and 0.0059 as my numerator. What I'm actually going to do is I'm just going to type these into the calculator, the BCD form, just so I'm getting the most accurate version of the answer that I can, rather than using these rounded answers. If I do that, I get 0.9378 as my final answer.